Okay, Fred, since you're pretty dumb, we're gonna give you two formulas that you can remember for the areas of shapes.
Yes, and it'll cover all other shapes, like every shape.
We'll show you.
These are the two formulas you need to know, Fred.
So, for counting these as units, the length of the base, since it's at the bottom, that's how you remember base. But, this right here is the height. This is how tall it is. So, in the case of our units, this is 2 units tall.
And this formula works for squares too, since they are basically the same thing as a rectangle, but more beautiful.
Basically, the perfect.
Yes.
See, rectangles suck because they're not perfect.
I know, a perfect rectangle is a square.
Exactly. This right here is a parallelogram. So you may be wondering, how do you do base and height with something that's crooked? Well, I don't know if you noticed, but we can turn this into a rectangle. So if I take this piece right here, chop it off right there, drop it on the floor, pick it up right here, and then I don't know if you noticed, but that looks like a rectangle to me. And now if we look here, here's a base and a height. So we have a base of 4 and a height of 3. And that's applicable to this formula right here, which you will remember, okay?
So to find the area of a triangle, it isn't really applicable right now, the formula right now. But let's see, if we have 2 triangles, as you see, these 2 are congruent in size and shape. So if we rip this triangle in half and rearrange it onto this triangle, as you can see, it becomes a square, and now the formula is applicable. So this would be 4 and that would be 3. So base times height. And since, as you can see, it's made of true triangles, the original triangle would be half of the original formula. So the formula of a triangle would be 1/2 of base times height.
Shh, you're not supposed to remember this one, okay? You just gotta remember that it's made out of 2 triangles, so you only use 1 triangle.
Yeah, exactly. So it's halved.
So it's half of that rectangle,
Yes.
but it's still a rectangle. We're dropping everything. So, what the frick do we do with a trapezoid?
Here's a trapezoid. As you can see, the top lengths and the bottom lengths are different, so you can't really apply that formula right now. But if you have 2 trapezoid that looks exactly the same, and you flip one and have them like this, you can see that it becomes a parallelogram.
So you remember how I cut off this piece right here and put it on this end, and I made a rectangle.
Yes, so it's just basically a rectangle now. It's a parallelogram, but you can make a parallelogram into a rectangle, so it's a rectangle. Yeah, let me think. Oh wait, let's not cut it. Okay, let's not. As you've already learned in the triangle, it's 2 shapes, so this would be half of this. So as you can see, this formula applies to this, and this bottom base is basically this plus this, right? And that is the bottom length, and this is the top length. So you have to add the bottom to stand for base bottom times base top. And since this is the half of this, it's half. But you don't have to remember this because I showed you how to do this.
So also, I have another little treat for you. This is a kite. Now, you may be also wondering, how the heck do I make that into a rectangle? Well, I'm going to show you how to make that into a rectangle. I'm going to take this kite. I'm going to chop it in half, vertical ways. So now that I've cut it into 2 pieces, I'm going to cut this piece in half after I turn it, vertical ways also. So when I take this, I look at this longer piece. It can be put right here. And this little piece can also be taken and put right here. And if you notice something about this thread, that looks like an awful lot like a rectangle.
But when it was originally a kite, you just need to... Okay, so for the kite, the formula is this one, diagonal 1, we're going to call that D1, D1 times D2, D2, but halved. How did we get this? As you can see, when we rearranged it like Rose did, the length of D2 doesn't change, but D1 has become halved. So, there we go.
Now you may be wondering, what the frick this is? This is pi r squared. Now, if you don't already know, because you probably don't know because you forget everything because you're stupid, this is the formula for the area of a circle. See, we can't use, well, you technically can, but you'd have to do it an infinite amount of times,
And you're stupid, so you probably won't understand it anyways.
so you really won't understand how to do that. But since this is a circle, you can technically cut it an infinite amount of times and make it into a rectangle.
Yeah.
Okay.
So, if we do that and rearrange it, it becomes like this.
Hard to believe, you know? But it's hard to believe because you're dumb. So, but we're not talking about that right now. Because we know that you can remember 2 formulas because somehow you've made it through your whole life without remembering every formula that you've done. I don't know how you've taken tests. That's insane to me. So this little dingle hopper right here, this isn't pi. Now, I can't write pi on there because it's infinite. But you have a button on your calculator that'll help you look like that because it looks exactly like this thing. This is the radius of the circle. So let's say that the radius of the circle equals 2. So the radius is how far it is from one side to the middle of your circle. And then you square the radius. So hopefully you know what an exponent is. I'm not sure yet. Figure that out.
It's just R times R. There's 2 R's timed together.
Exactly. So that's how that works.
Okay, this is a semicircle. You may be wondering how you find the area of a semicircle. But here, if you have 2 semicircles, as you can see, it just becomes a regular circle. So a semicircle, as you can see, is just a half of a regular circle. And
It's the triangle of circles.
Yes, exactly. So you just need to know that it's 1/2 of a circle. But you don't need to know that because you just need to know it's half of a circle.
Exactly.
And you already hopefully remembered the formula for a circle, which is this one.
So now, Fred, we taught you 2 formulas and showed you a little bit about these formulas. The length of the base times the height is for anything that you can turn into a square or rectangle. And so pi r squared here, that's for circles. So anything round, okay? Don't get any ideas on try to use that here because it won't work.
Yes, but this would technically work on a circle, but you're too dumb to know it, so there you go. Bye, Fred.
So
Okay.
So, fun fact, all rectangles are squares, but not all squares are rectangles.
Okay. Let's.
You're talking to a phone, I hear.